more distance, better audio, and a conversion to 160 metres. All this and more in part 2 of my discussion on a simple wooden block drawing pin AM transmitter.
Thomas, including birds sing joyfully.
Here's the circuit I presented before. The capacitor values I used were around 220 picofarad, which gave 1300 kilohertz. I replaced those with around 150 picofarad, and that got the frequency up to about 1850 kilohertz, which puts you in the 160 meter amateur band. So with just those two small component changes, I've now got a transmitter that transmits on 160 meters. It's still going to be very low power, so you'll have difficulties being heard much more than a few houses away. But there's ways around that, as I'll talk about later on. One thing I found with this was that, as you might expect, this was not pure AM. It was actually more like FM, which figures because if you put your finger on this point, the frequency does change quite a lot, more than 50 kilohertz. After all, we're right near the inductor, which is one of the frequency determining elements of this transmitter. Applying a bit of audio here from the audio amplifier gives you a little bit of a frequency variation, which is what FM is all about. You can still hear FM on an AM receiver, you just have to tune off to one side of the center frequency, and provided your deviation is not much, you can still get quite a clear reception. One thing I found, and the source circuit didn't have this in, a capacitor from the positive rail to earth. I've used 10 nanofarads, but you could use 100 nanofarads. It's good to have this capacitor to ensure that any RF floating around is shunted back down to earth potential. One other thing I did was to put in an extra 120k resistor from effectively the base, at least as far as DC is concerned, to ground. That holds the base at a middle voltage point, and it resulted in a little bit clearer audio. So just for the cost of 5 cents, I thought that was worth doing. It also seemed to be a little bit more stable and better behaved. Another thing, and this is probably what you're here for, more power. I've got one extra transistor, a 2N2222. It's 100k resistor there. I'll just zoom in on it. It got quite hot when I first put it in, when I had the emitter shorted straight to earth. I was getting about 100 milliwatts output, so I put in this resistor here, 33 ohm, and it's more like 40 to 50 milliwatts output, but the transistor no longer gets hot, so I thought that was fair. 47 microhenry RF choke in the collector circuit and running it off 12 volts positive. So we're now up to 3 transistors and 50 milliwatts. As for the circuitry itself, well, as I add more bits, it's getting messier and messier. This is the final transistor. It's a metal can type, but if you've got the plastic type, it should work okay. This is testing the transmitter, receiving in the FM mode on 160 meters. Testing 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Something that can happen with small transmitters is motorboating and oscillation. Here's an example where it's actually a broadband noise source, creating interference all across the spectrum. Here's how I tamed it. I just put my finger on the earth. Even better is if you use a proper wire. And when I tamed it, the signal is clean and you can actually hear it. One, two, three, four, five.
They are purely physical, like the banshee, etc. Then suddenly, you see this 4-foot-high human-shaped creature enjoying the sun and fishing in a river, and no one has actually asked for it. They are out there, but still.
Right, listen, Ross, I'll have to take your word for it because they're running out of time, but take care of yourself, man, and thanks for talking to us. We've got to go. I'm sorry. Bye.
Tuesday partly cloudy, 14, and on Wednesday it'll be a partly cloudy day, 16.
I got about 800 metres from this when I did a test walking with a portable receiver. So it's still not what I'd call suitable for getting amateur contacts unless you had hams very close by. However, there are some things you can do to further increase the range. Probably the most important is the antenna matching. I used an end-fed wire about 35-40 metres long, actually part of a HF antenna. A lot of it wasn't very high, a lot of it wasn't vertical, and the earthing system wasn't very good. But even worse was I had no matching between the transmitter's output stage and the antenna. The output stage at these low power levels is high impedance. It might be several hundred, maybe even 1,000 ohm. And the antenna, especially if it's a short wire at a low frequency, will be very low, well under 50 ohms. And it will probably present a reactive load as well. So to get optimum power transfer, you'll want to have some sort of matching network between the transmitter output and the antenna. Not to mention a low pass filter to suppress harmonics. Otherwise, if there was a ham very nearby on about 3.6, 3.7 megahertz, then they might hear a signal from you, even though you're actually transmitting on 1.8 megahertz. And even worse is the potential for harmonics in non-amateur bands. This becomes more important the higher the output power you go. Another thing you might want to look at is the modulation quality. You can get by with poor quality modulation when you are close to a transmitter, but the further away you go, the more important is that you have punchy audio. And that's where you need to do a lot more with this circuit. Then you'd have a proper AM modulator, and that can drive a final amplifier stage. You need more power, both the RF and the audio, and an appropriate transformer in a lot of cases. But once you do that, you have true AM. That's okay, but not perfect, especially if signals are very low. You could even try converting it to a crystal oscillator if you are happy with a fixed frequency. You can also increase range by using a better receiver, not just the portable that I was using. If there is an amateur using a proper receiver, especially if they had a tuned receiving loop that they can turn to null out interference, maybe my range would have been more. Instead of 800 meters, maybe it would have been 1.5, maybe 2 kilometers. And if there was a big body of water between us, the distance could be even more. And since we're still dealing with small amounts of power, all I'd need to do is to add an extra transistor. I would say a BD139 and that will get your power up to maybe 1 watt. Yeah, at least 1 watt should be possible from a BD139, maybe even 2 watts. And that will, even if you did nothing else to the antenna or other aspects of the transmitter, that will give you longer range. I'd say maybe 3 or 4 kilometers. So just thought I'd throw these hints in just in case you're interested in building a transmitter like this and getting a bit more range. And I definitely suggest a better style of construction if you're going to be using this seriously, like probably metal boxes and shielding the transmitter part. You saw the motorboating before. That is a direct consequence of construction that isn't ideal. Like, look at the long lead on this capacitor. This capacitor there is the 10 nanofarad, the one between the supply rail here and the ground, and ideally you want that to be a much shorter connections because you've got some stray inductance there. You might have some coupling, and if you look at the coil here, it's an RF choke. It's possibly not the most stable. Neither are disc ceramic capacitors, especially if they are the cheaper type. Capacitors known as NPOs are a bit more stable. If you've got mica capacitors, which can be hard to find, but you might be able to get them from old equipment, that's better. Polystyrene is another good type of capacitor. But overall, if you've got a free running oscillator, it's better to have a few more stages between it and the antenna, and that's why having an extra transistor on here will give you a bit more power output and probably a bit better frequency stability. So just a few thoughts about this super simple transmitter. Just add a few more things a day or a week at a time and you can get longer range, and it could even be practical for amateur contacts.